Greetings everyone, thank you for joining me. We're going to do another video. This time we're going to transform the function x cubed. Now the reason I know that we're transforming the function g of x equals x cubed is because I can see this cubed up here, which means the parent function was x cubed. In order to do a proper transformation, the way I've been teaching you, you need to be able to identify several ordered pairs on the original function, the g of x equals x cubed. So the standard ones that we usually use for g of x equals x cubed would be -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. Now we're going to change those ordered pairs dictated by the changes that have been made to the function and what we see in the f of x equation up here. Well, I see a -2, I see a -5, I see a minus directly in front of the x, and I see a minus in front of the entire equation. Each one of those is going to cause some change to g of x, and we're going to change the ordered pairs accordingly. The -2 here at the far right is going to make the whole graph shift down 2 units. The way we accomplish that is we subtract 2 from y. The -5 on the inside is actually going to shift the graph to the right 5 units. That's the one that's backwards from what we think we should do. But shifting to the right 5 units is accomplished by adding 5 to x. So we're going to add 5 to x. There's a negative sign directly in front of the x inside the parentheses. That's going to do a reflection over the y-axis, but what that does is it changes the signs on the x value. Changing the signs on the x value, another way to say that is multiply x by -1. Finally, there's a minus sign in front of the entire equation. A minus sign in front of the entire equation reflects us over the x-axis, but the way we accomplish that is we change the signs on y, or multiply y by -1. All right, we're going to have to do 4 things, everyone. Order does make a difference. We should do the horizontal shift first. We should do the vertical shift last. And the multiplying the x by -1 and the multiplying the y by -1 can actually be done in any order. But I like to finish with my x's before I move on to my y's. So I'm going to do it that order. All right, 1, 2, 3, 4. Here we go, getting our new ordered pairs. We can always do this in 4 steps or less, so this is going to be one of our longer problems. And the first thing I need to do is I need to add 5 to all the x's and leave the y's alone. 3, -8, 4, -1, 5, 0, 6, 1, 7, 8. Added 5 to all the x's, left the y's alone. Next step. Leave the y's alone again, but multiply all the x's by -1. -3, -8, -4, -1, -5, 0, -6, 1, -7, 8. Left the y's alone, multiplied all the x's by -1. Now we're done with the x's. The x's are going to stay left alone for the rest of the problem, but our first thing we do with the y's is multiply them by -1. It won't do a thing when we multiply the 0 right here by -1, because multiplying by 0 just gives you a 0. All right, let's see what we got here. -3, 8. Leaving the x alone, multiplying the y's by -1. -4, 1. -5, 0. -6, -1. -7, -8. One more step and we'll be ready to graph. Our final step is to subtract 2 from all the y values while leaving the x's alone. So that's going to be -3, 6. -4, -1, -5, -2, -6, -3, -7, -10. You can take any one of these ordered pairs in our bottom row, take the x value and plug it into this original f of x function up here, and you should get the y value. That's just a good safety check to make sure you got the correct ordered pairs at the end of the problem. So check 1 of them, check 2 of them, check all of them if you have time. But you can always make sure that these final ordered pairs work in the f of x function we're trying to graph. Let's graph it. So I put a coordinate system here for us. We're going to plot our points. So we've got one point at -3, +6. Yep, that looks good. Then we got another one at -4, -1. And so let's see this a little better here. -5, -2. -6, -3, and then -7, -10. You got to kind of go all the way down here. Now, these are tricky to graph, everyone. We do see the basic x cubed shape here, even though it's been messed with, flipped, reflected, shifted, moved around. But this is a really important point right here, this -5, -2, because that's still kind of the hub of the graph right here. That was the one that was at 0, 0. One thing that kind of helps me to draw these graphs is not try to go from left to right, but kind of work from the inside out. So kind of got that like that, you see, and then move your way up to that point and down to that point. You get a pretty good looking graph. By the way, the domain and range of the original x cubed function are both -infinity to infinity. So it's the same thing with this transformation. Okay, I hope that helped. Thanks for watching.